As Nicolas said, my name is Jéfte.
Oh,
um,
yeah, sorry.
no, I did not I did not try to correct you. It was because it's like normal to it comes up normally, and I'm a software developer. I'm based in Montreal, and uh, thank you all for being here. It's always a pleasure to talk about technology itself. I don't know if you are like me, like a nerd, but I like to talk about technology and even startups and this kind of things. And being in meetups, in the Elixir meetup, it's a real good place. When you meet in real life, we can talk about all sorts of things, and it's really cool. It's really cool, and thank you for being here, in fact. And as Nicholas said, we're gonna talk about pattern matching today. It's a principle uh, that's all around Elixir. Elixir is like at in every production code we see pattern matching is the first thing we see too when we are learning Elixir. So what I'm gonna do is show you basic facts, basic concepts, and sure, if you like, Nicola said, if you are an advanced user, you won't learn a lot. But when we are starting, it's it's cool to listen about how things work, and talking about pattern matching is like important because I don't know if it's the same experience for everybody, but for me it was like difficult to understand at first because it's not something we see in C sharp. For example, I'm a C sharp programmer, and in C sharp the equal sign works totally different. And Elixir we kind of have to reprogram the way we think, our mindset. So I'm gonna share my screen. Mm, Ready, share. Do you see my screen? Good.
Yes.
So understanding pattern matching, a closer look at Elixir's pattern matching. This is the title of the talk. It's not too long. It's compact, and I'm gonna show you the basics about pattern matching. And for starts, what's pattern matching? Well, pattern matching is the process of comparing a given value or data structure against a pattern to extract or bind values according to that pattern. In Elixir, it works by using the match operator, once known as equal sign. In other languages, we call that equals normally, but in Elixir, we call that match operator. There are other languages that have pattern matching. C sharp has pattern matching, but it's not integrated in the language at the same level that we have in Elixir. And I think it makes Elixir a little magic because when you start to program in Elixir and you start to easily extract values from maps, from tuples, from lists, you start to see the productivity and the readability that pattern matching gives to you. And I'm going to show you the basic syntax and explain what pattern matching tell to Elixir to do. And we're gonna learn by doing, but I know you you probably already know. But there are some hidden facts that for me was like cool to learn and understand, and I discovered it like after 6 months learning Elixir. And when we learned that, we have the click, and things change in our heads. I've uh, caught myself trying to use pattern matching of Elixir in C sharp. I was like programming, and what the fuck? What is that? Oh no, I just did the Elixir way. It's not the the C sharp way. So look at this statement: X matches against one. If you're gonna search in the internet about how to read that, that's not there's not a consensus about how to call it. X equals 1, equals binds to 1, equals matches against 1. I, I say X matches against 1 or binds against 1. But it for your you call like you want. In this case, we have uh, an unbound variable that is being matched to the value 1. This in Elixir we call binding. We have a shape, a form, and we try to match this shape to a value. When this match succeeds, we bind this value to the variable and return the value we are matching against. Is it clear? Doubts? No. Okay.
Okay.
Uh, and you are seeing the just the Prezi? Is that right?
Yes.
Okay, good. And if you want to play around, uh, we can we can try the other way around. We can try to do like one equals x or one matches against x. We cannot do this in other languages like C sharp, by example. You cannot try to assign a value, a variable to a value. It's because in Elixir it's different. In Elixir, we do not try to bind anything. We not try to assign anything. We try to match and bind the value in the right hand side to the value in the left hand side. And when you try to do one matches against x, what we are doing is the pattern, the value one, is being matched against the variable x. And as the integer one is not available to bind, we just do a match between one, the value, and the variable x that has a value one bound to x, to the variable x. Do you understand? I have one matches against the variable x that has the value one. 1 equals 1, 1 matches to 1, it will succeed. We won't bind anything, and we're gonna return the value 1. Is that clear? But we are playing around. We're gonna try to do 2 matches against x. There we're gonna have a match error. Can you say why? Because the value 2 in the right hand side, it's different from the value bound to the variable x. So 2 does not match 1. So we have a match error. We, for me at least, I saw that a lot when I was starting studying Elixir. And there's a case of binding and matching. But Elixir is immutable, but Elixir supports rebinding. What's rebinding? It's the when we try to match a bound variable, there we have the variable x, the variable is bound to a value, the value is 1, and it match to 2, we do x matches against 2, we do a pattern matching. This pattern matching will succeed. Why? Because in this case, we are matching the pattern to the value, the form, the shape, x to the value. You have one variable, we match to one value. When the match succeeds, we bind the value to the variable and we return the value you are matching against. That in this case is 2. Does it make sense? And thus we have rebinding. This, for me, is like tricky because you have a variable, you are coding, you forget that you named the variable x, and you rebind it without without no. So the variable changes, and you get errors. Sometimes you get lost. I've already got lost in a assignment I have to do in Elixir because of that. I rebound a variable that did I did not want it to rebind, and I got error in my tests. Why? Because I rebound a variable that I should not have rebound. So it's a little tricky, but you can make this more strict when when you use the pin operator. The pin operator is the I don't know how to say that in English, but is the accent circumflex uh, behind the X. And when we do that, we are preventing Elixir from doing rebinding. So when you try to match a pinned variable to a value, we are not matching only the shape, we are matching the shape and the value. So we're gonna do the pattern match against the shape x, the pattern x, and the value we bound to this variable. So if we do pinned x matches against 3, we're gonna have a match error. Why? Because it's pinned. So we can't do rebinding. I can okay, so it's good. Uh, so oops, got lost. Okay, this is the basic syntax, the basic case of match operate, the match operator of the pattern matching. But Elixir supports pattern matching in more complex structures as lists, maps, and tuples. And when we start to code in Elixir, we see that it makes really easier to work and extract values from complex structures. And it's like common idiom in Elixir to extract values from maps, by example, by using pattern matching. I'm gonna get there. Uh, for this statement in lists, we have the exact same case we had in the basic syntax. We have a pattern, we have a shape, a variable list, that we are trying to match against the list 1 to 3. That's gonna work because we are only matching the shape. So we're gonna bind the value 1 to 3 to the variable list and return 1 to 3, the list 1 to 3. Understood? And we can play around when we are using lists. Lists are more strict for pattern matching, but Elixir gives us the ability to decompose the list and extract values of the list using the pipe. As we see in the second statement, we have the list ABC that we can pattern match to HD pipe TL. What does this do? It extracts the head of the list from the tail, and it matches because we are matching the pattern, we are matching the shape, and we are not changing the shape of the lists. So we do 3 pattern matchings, and the 3 work because we are matching the shape. And to a value, and the value is 123, the list 123. Understood? And it works. But if we want to have an example of how to throw an error, we can see the third example, the third statement. We have a list DE and we have a list AB1. This won't match. Why? Because when we are matching lists, we are more strict. Elixir is more strict when we are matching lists. We have to think that when we want to match lists, we have to respect the order of the items in the lists and the count, the length of the lists. So DE won't match to AB1 because the count is different. We're gonna have a match error. And another structure we can match in Elixir, we can use pattern match easily is tuples. The fourth statement there, we have the tuple op result and underscore that matches to OK and a message. This is common idiom in Elixir. I don't know if you already saw this, a pattern match for tuples in Elixir with the atom OK. Did you got that in codes? So it's common when we are using Gin servers. We generally return the atom reply and the state, or no reply in the state when we are doing casts and calls to Gin servers. When we are using Ecto, if we don't use the bang the bang signal that is in Ecto, we can do repo dot one, and it returns OK, and the item we are searching. But if we use the bank function, that is repo dot one with the exclamation, it will return just the value. So Elixir has this idiom. Uh, Sometimes we want to return the status of the operation and the value we are searching, or a message, and there we use pattern matching in tuples. And I'm gonna show you in code uh, after in this talk, but just get in mind that it's common idiom. It's used everywhere, and don't do this that I did in the example. In this example, I matched op result, that's the atom OK, and the underscore, that's the variable, the string match succeed. When you do the pattern match with the underscore, compiler just ignores the 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 element in the position where we put the underscore. So we cannot retrieve, by example, if I do, I'm gonna try to share my terminal after I do this for you. uh, when we when we when we do this, we ignore the value we are matching. So for the good of the mental health of your colleagues, try to do underscore and the name of the variable, so we know what we are ignoring, you know. So the good thing to do would be match op result underline value to the atom OK and the string match succeeded. Is that clear? Good. And yes. Hello? I understood something. So, Elixir supports pattern match in maps. As we know, maps are important, big time in Elixir, and I think it's like the most important data structure in Elixir, and everything everywhere gonna use maps to in order to model data. So Elixir allows us to pattern match in maps and allows us to extract values. You see in this statement, that we are matching the map that has the keys name and age to this second map that has the key name and the values Jéfte and the age is 18 because I'm 18. And this pattern match, we're gonna will succeed because the keys are the same, the shape are the same, the match will succeed. And the cool thing I find in this pattern match is we can extract the variables and use it independently in our code. If you have this statement, we are binding the variables name and age to the values of the keys in the right hand, name and age, so we can use those variables after in the code in the same scope, obviously, but uh, extracted from the map. And for me, it's really cool. Why? Because when we are programming, say, a REST action, you have a post that receives a payload, and we want to assure that the key X is present in the payload. We just have to say in the parameters that we want a map that has the key name, by example, or the key X, and we're gonna do the match. Or if we have another function with the full clause, we're gonna fall there if the key we are demanding is not present in the map we are passing to the function. It's really cool because when we have uh, oriented oriented programming languages, what we have is we have an object, a big object, and we have to receive the structure we have. If we want to extract value, we have to get the structure and object dot property name. In Elixir, we don't need to do that, and the map itself can be everything. We just have to match one key. And uh, the second statement shows us this fact. We are we are matching the map name with the variable name to the map that has the key's name and age. And this map will succeed. Why? Because the key we are demanding in the left side hand exists in the map in the right side hand. You know it. It's awesome for me because when you are in code, real code, you can like control flow atomically. You can use just the variables you want to use just when the key is present, and you can do fallbacks really easily, and I'm gonna show you that. But we can have match errors too when we are matching maps. It's less strict than lists, but uh, if you try to match a map that has a key in left side hand that it's not present in the right side hand, we're gonna have a match error. And it's cool too, because if you want the name and age keys, but the payload you're receiving does not have that, you don't need to check this inside the function. You don't need to do map contains key. No, you can just pattern match and create a fallback to treat the case where the key is not there. And it's awesome. It's awesome when you code in Elixir. Uh, we see this easily, and I'm gonna show you this uh, right away. I wanted to make clear when matching lists and maps succeeds, because when we have this in mind, we can work more fluidly, because we have in mind what we're gonna need in order to do the pattern match with list and maps. So what are the restrictions for matching values, list values? Is the order of the items, the two lists or three lists, doesn't matter. The lists we are matching have to have the same order for the items. The items the right hand side must be the same order of the items in the left hand side, and the count of the lists. The list must have the same length. So there are two rules to pattern match lists, and for maps less strict. The only restriction is the keys demanded on the left hand side must exist in the map in the right hand side. Is that clear? And man, it's like useful when we have this in mind. It's useful because when we are starting, in my case at least, i i made I made myself like, I'm going Elixir is a language with no type. you know I can just pass the variable state and try to access the properties inside of that. But sometimes it doesn't work because the structure we create is like complex, and we forget the name of the keys, and we have a bunch of match errors because the keys does not exist. So when we try to pattern match with this in mind, I have to have the keys in the map I'm receiving as a parameter, for example. It makes the things easier. At least for me, it made the things easier. And there are a bunch of positive things that come with pattern matching, like better control flow. Uh, we have more readability, and but a thing that I love in pattern match, a feature that is enabled by matching that I love, is multi-clause functions. It's like common idiom in Elixir 2, and it makes super easy and very and makes us to create a code concise without effort, because pattern matching does it for us. And one of these features that we have is multi-clause functions, and multi-clause functions are uh, the possibility of having multiple heads for a function and treat each input differently. Uh, Multi-clause functions are common idiom building Elixir applications and make our code more declarative and thus readable. And it allows us to create atomic small functions, naturally guiding us through the single responsibility principle. I'm going to show you an example there. That is this. We have a module animal and the sound that the animal do. For each species we return a sound, and we don't know the animal. We just say, hey man, I don't know what is that, you know. And when we have multi-clause functions, we can pattern match the parameters we receive uh, in the function to a value we're gonna treat that we're gonna treat differently. When we receive a species dog, we want to the we want to we want to the function onomatopoeia returns a wow. This is one responsibility for one case. This function has one responsibility for one case. When the specific cat, the same thing. And when we pass underscore, we just match everything. And it's important because in Elixir, I've committed this error. I put the more specific, the less specific case at first, but when we are writing Elixir, the compiler try to match from top to bottom. So if you put the underscore the underscore function in the first place, it's gonna match always. It's always gonna match. And but it's cool because Elixir shows us this error. When you try to do this, put the less specific case at first, at top, Elixir say, hey man, you are trying to match something that will always match and the other clauses won't match. So Elixir is intelligent to this point. It's like really, really cool for me. And now we have, in comparison, a function. We can export this as a module, but I just create a const animal that receives the function onomatopoeia, that receives the parameter species, and we check what's the species, and if we don't know the species, we return what, I don't know, man. And there, I don't know if you see like I see, because I know that this function in JavaScript, it's not good. It's not good JavaScript, but I did this way because I wanted to make a point. I exaggerated to make a point. You see that the function has an if else that can grow a lot, and the the one function has three responsibilities: treat the case dog, treat the case meow, and treat the unknown case. Sure, we can rationalize and say, but the responsibility is to return a sound. Okay, but if we do it more specifically, more atomic, we have a concise way to code. And it's the it's not like in Elixir, it's not like we override the function. It's not that. We just have various heads, and we can have, just by example, one test for everything, and it'll be concise. You see that it's like, for me, it's the clearest way to write code. It's doing pattern matching and treat the inputs even before work inside the function. It's I love it. I love it. And you can even extend that with guards. You can create custom guards. You can do a bunch of things just knowing how pattern matching works in functions. And it's important. I think it's good to know all the contexts we can apply pattern matching. And in Elixir especially, it's like everywhere you're gonna use, everywhere. And multi-clause functions was one feature I chose to explain one of the good things pattern matching brings to Elixir. One of the good features that make our code better. No, but there are more. I'm not gonna talk here because it's enormous. So wrapping up, pattern matching is all around Elixir, all around it. From control flow, I can show you uh, happily. Uh, my I'm trying to share my terminal. I can't in this moment, but I'm gonna show you. I'm gonna show you. Uh, Pattern match reduces the complexity of our code, as we saw in the comparison with JavaScript. Uh, there are a lot of more use cases, like pattern matching on binaries. Man, I don't know if you know the JSON serializer JSON, the Elixir uh, JSON, the serialized Elixir JSON parser. Man, I saw the code and it's built with pattern matching inside binaries, and it makes a blazingly fast JSON parser. So it's cool to see the code, and if you want to, you can create a JSON parser using pattern match. You don't need to go deep and try to do the binary thing, because it's a little more code. But if you want to do in one sit, you can apply pattern match, creating a JSON parser. Uh, and in fact, I'm gonna show you my GitHub test just to show you uh, how we use pattern matching everywhere in our Elixir codes. Um, Wait a little minute. I'm gonna share another thing. It's gonna be fast. Okay, Proto Hackers. Do you see my screen? Do you see there? This we start with this. Elixir has supervisors. Elixir and the start link is a
Can
common
you zoom in a
function.
bit?
What?
Can you do zoom a bit?
Okay.
Mm.
Quanto mais. It's better.
Yes, thank
Yes.
you.
We can also zoom ourselves the presentation. If you see we have a little loop in the right side of the shared screen, and we can do the zoom ourselves.
Do you see it? Here we have a case of pattern matching on tuples, and everything everywhere that has supervisors engine servers, we're gonna do something like this, because the common idiom is return the status of the function if we received an error or not, or if it was okay, and the supervisor in this case. Here is another example when we have uh, here in this case we have a GNTCP that has the function list. We pass the port and the options, and it can return a tuple with OK and socket. And when it's OK, we do this. And when it's an error, we do this. You see that the pattern matching here is it's not clear, but it's what we're doing. We are passing a value and trying to match against patterns. Do you see it? It's like everywhere. Here, another case. Here in the parameters, in handle continue, we have a case of pattern matching in maps. And in this case, I want the map that has the keys, socket, and supervisor. If my state does not have the supervisor, it's gonna fail. And you see that is how can I say that? I'm gonna stop the presentation. Do you see how it's concise? I think it's the word. It's concise. We have the values we want to match, and we can we can treat every patterns we want to, and it's declarative. It's there. We don't have to think a lot about we are receiving as parameters, or about the things we are returning from a function. We just have to say the keys, declare the keys we want to match, and it's gonna match. So I think it's like, for me, it's a super feature pattern match in Elixir. You see, so it's just one example of of how pattern matching is present in Elixir and how it can make our code better, and how it how it makes us better coders. For me personally, I don't know your experience with Elixir, but in my experience, I'm gonna I, I'm gonna know. I'm being formed again. I'm burning. I am like starting as a programmer. I feel like I reborn as a phoenix and as a better coder. More declarative, more concise, more single responsibility focused. So uh, pattern matching is more than that, but uh, you can study it by yourself and see the benefits of it. So questions, comments, insults? If not, is that it's the end. So merci bien gros.
Yeah, thank you very much for this presentation. So, do we have any question for Jéfte? Jéfte, sorry.
Yes, just one question about Elixir and
Yes.
pattern matching, because I saw pattern matching in other languages, and it seems it's similar bit. Just one question: does Elixir support discriminated union types?
No. In fact, at this moment, what we have is we have maps. We don't have types in Elixir. We have, I think, 8 types, 8 simple types, and it's that. And it does not. You are talking about Haskell. It's that Haskell. I think
Even TypeScript has the
Yeah.
discriminated union types. So
in Elixir we don't have that. How can I say that? We don't have.
is it possible even to model it with specs in
It's
Elixir?
yeah, it's because for now there is no static typing in Elixir. You have optional specs where you can annotate your functions to define types, but it's not yet strictly in the language.
It's like being studied. There's a study for.
Yeah, they're working on implementing that. They started a year ago or something, so they're working on it, having static types. But for the moment, it's not in your specs. You can say like the discriminated union. You can say like you can have a union
Mhm.
in
Yes.
your specs, but you cannot use that directly. Well, you will use pattern matching, so then yes, but it's not like if you change. I don't know if you change your type signature. Will
In
it?
fact,
You won't compile.
it'll compile and it'll work even if the type spec you put
Yeah,
is
it's
not good.
incorrect. Yeah.
Because it's like an annotation to guide you in your development, but it's not tied to the compiler. But
The
when you use
static analysis more than
yeah, but you can do when you do pattern matching in practice, you are working with discriminated types, not by the type itself, but the properties, the subset of keys the on the maps you are matching. You understand? If you match, you have two maps, and one map has keys that exist in other map, and when you're gonna match it in practice, you are like typing it when you have a match with the keys and everything, but it's not tied by the compiler.
yeah.
Yeah, you have at runtime you have pattern matching, so you can have your case and then you pass your variable or whatever you have, and then you can say, okay, if the type is this, do that. If the type is that, do that, etc. That's within a function. Or as Jéfte presented. It's very common to have a function, and in the signature of the function, you say, okay, if the input looks like that, I execute. And if not, it will look at the next function and the next and the next until it finds a function that matches. And if no function matches, it
Gonna be an error, a match error.
match error. Yes.
Yeah, I understand why the lack of typing makes me understand why pattern matching is implemented like this.
Yeah, it makes sense.
Yeah, thank you. Interesting.
My
Nice.
pleasure.
Any other question?
I have one thing to show to you.
Nice.
Wait just 1 second. I don't know if you are actively studying. I'm gonna send the link in the Discord. But I have a friend, Lubier, that is creating a side course for Elixir, and I'm gonna send it to you. I think I'm gonna send in the Discord. But
I will put that in the recording talk description.
okay, where how it
So
how's it
everyone
called?
can access it.
Adopt live view. Wait a little. Adopt live view. Adopt live view. .lubien.live. Okay, I'm gonna send you it. It's very cool. The site my friend is creating, it's work in progress, but he's going to add unit tests, live view, even Ecto. He said me he's gonna put Ecto sections. So it's a good site to study. And another place that I love is Learn Elixir Dev. Do you know Learn Elixir Dev?
Let me see. Oh.
We have a beautiful site now, and there are resources to learn Elixir and evolve as a Elixir program. It's really cool. I'd reach these sites if I want to learn a little more. If I was you.
Interesting.
So
Cool. Thank you for sharing. All right, I will put the links in the talk description and the link to the presentation as well. Thank you very much, Jéfte.
Thank you.
I'm gonna wrap it up. So, if any one of you wants to present something at some point, it could be in English, it could be also in French. We'll try to get a host to have it in person, but if it does not happen in person, we'll have it online. With that said, I wish you all a very good rest of your day or evening, and see you next month.
See you next month. Thank you. Have a good night.
Bye bye.
Thank
Thank you,
you.
Jéfte.
Bye.